Hello. So today we are going to discuss the topic differentiation. So for this first part, we are going to focus on the differentiation for the first principle and the first derivative. So now we have the differentiation for the first principle. So derivative of a function. So meaning that I'm going to show how we have the differentiation. Okay, so kindly refers to the formula. So in here we have the situation f prime x. So basically what is f prime x? Okay, f prime x means that the dy dx. Okay, or we can say the gradient. So what is the formula for the first principle? So limits when h approaching 0 for the function. In here we have f bracket. With the value in here we have x plus h minus the function of fx over h. F is said to be differentiable or has the derivative if f prime x exists. So when we have this kind of situation, given the function, we have y equals to 3x plus 2. So if we can straightforward differentiate the situation, so we will have dy dx is equals to 3. But in here they mentioned by using the first principle. So how to get it done for the first principle? Meaning that we have to refer to this instruction.
So given the formula f prime x is equals to limit when h approaching 0 for the function f x plus h minus the function fx over h. So now let us begin with the discussion. So f prime x is equals to limit when h approaching 0. Next we are going to sum the function 3x plus 2. For the x will be x plus h. So 3 bracket x plus h plus 2 minus for the function fx. So here we will have 3x plus 2 over h. Next, I'm going to expand the situation. We will have limits when h approaching 0. 3x plus 3h plus 2 minus 3x minus 2 over h.
So kindly refers to the situation. So in here, actually we are just substituting the situation. So you can see or not, we have f bracket x plus h. Means that substitute the x with the x plus h. And then we have fx, so means that straightforward bracket 3x plus 2 over h. Then expand. Then kindly simplify the situation. Then we will see what happened.
Next, we're going to simplify the situation where we will have 3x minus 3x, h, 2 minus 2. So finally, we will have limits when h approaching 0, we will have 3h over h. So at the end, we simplify and we will have limit when h approaching 0, 3. So f prime x is equals to limit when h approaching 0, the value 3. So finally, f prime x is equals to 3.
So in here we have the situation. If kindly refers to the situation y equals to 3x plus 2. If we differentiate straightforward, we will have dy dx equals to 3. Okay, same for this situation. Just that in this question, we are using the first principle. So that is the basic how we differentiate the situation. So another example. So kindly refers to this case. Again, we are using the first principle. So refers to the formula and we have two different things. One is differentiable. Another one is we have the derivative, which is the dy dx. So kindly refers to the example.
So here are the example. Given that y is equals to square root of x. By using the first principle, find the f prime x. So given the formula for the first derivative, or by using the first principle, we have f prime x is equals to limits when h approaching 0 for the function f bracket x plus h minus fx over h. So now we are going to use the formula to show that, or to find the f prime x. So f prime x is equals to limits when h approaching 0. For the function x plus h, we're going to sub x plus h into the function square root of x. So where we will have square root of x plus h minus square root of x over h. Next, we're going to sub the value. So now the h is equals to 0. So we have square root of x minus with the square root of x. And we will obtain 0 for the numerator. And for the denominator, if we substitute the 0, and we will obtain 0 for the denominator. So here we have an indeterminate form. There are several strategies that we can use to solve this kind of situation. Number 1, multiply by the conjugate. Number 2, factorizing the situation. So for this case, I'm going to multiply by the conjugate. So f prime x is equals to limits h approaching 0, square root of x plus h minus square root of x over h.
So kindly refers to the situation. So actually we are dealing with the limits, which is the basic for chapter 8. So for this kind of situation is IDF. So we have 3 strategy. Number 1 is multiply by the conjugate. Number 2 is factorization. Number 3 is long division. So for this case, we are using the multiply by the conjugate because we are dealing with the square root cases.
Next, I'm going to multiply the conjugate. So the conjugate would be square root of x plus h plus square root of x over square root of x plus h plus square root of x. Next, I'm going to expand the situation. I'm going to expand only the part of numerator. So f prime x is equals to limits when h approaching 0. If we expand, we will have x plus h plus with square root of x plus h minus square root of x plus h minus the x over h bracket square root of x plus h plus with the square root of x. Next, what we're going to do is to simplify the situation, and we have x minus x, we obtain 0, and we can simplify the situation and become 0. So finally, we have f prime x is equals to limits when h approaching 0, h for the numerator over h bracket square root of x plus h plus square root of x. After we simplify, we will have limits when h approaching 0, 1 over square root of x plus h plus with the square root of x. So finally, after we substitute the situation, meaning that 0 into the function h, and we will obtain f prime x equals to 1 over square root of x plus square root of x. So finally, f prime x will be equals to 1 over 2 square root of x.
Okay, so kita dah bincang ya dua contoh macam mana kita deal with first principle. So ini adalah arahan soalan, faham tak? So diberi situasi, so dia kata guna first principle, inilah formula dia. So mesti kena rujuklah formula ini. Boleh kot? Boleh ya? Okay, so ini adalah find the first derivative guna first principle. So seterusnya kita akan guna lagi satu formula, iaitu untuk cari value for that point. So untuk soalan ni dia berbeza ya dengan first principle. So formula yang diguna pun berbeza. Yang ini adalah nak cari that point punya dy dx. Maksudnya nak cari gradient pada satu titik tersebut. Dia bukan nak differentiate saja, dia nak cari dia punya gradient. So ini adalah formula dia. Okay, ini adalah formula dia. So mari kita tengok apa penggunaan dia. So ingat ada dua, differentiable dengan derivative.
Here we have the derivative of a function at a point x is equals to a. F prime a is equals to limit when x approaching a for the function fx minus fa over x minus a. F is said to be differentiable or has a derivative if f prime a exists. So here we have the example. Given that the function is equals to 1 over x minus 1, find the f prime 2. So given the formula, f prime a is equals to limits when x approaching a for the function fx minus fa over x minus a. So now we have to substitute the value. So f prime 2 is equals to limits when x approaching 2 for the function 1 over x minus 1 minus fa. So in this case, the a is 2. So we have to substitute 2 into x. So we will have 2 minus 1, which is equals to 1. So here we are going to write 1 over x minus 2. Next, I'm going to simplify or equate the denominator for the numerator part. So limits when x approaching 2, 1 over x minus 1 minus bracket x minus 1 over x minus 1 over x minus 2. Limit when x approaching 2, we will have 1 minus x plus 1 over x minus 1 bracket x minus 2. So simplifying the situation, limits when x approaching 2, we will have 2 minus x over x minus 1, x minus 2. Next, I'm going to factorize the numerator, where we will have limits when x approaching 2, negative x minus 2 over x minus 1, x minus 2. Finally, we will have limits when x approaching 2, negative. We can simplify x minus 2. So, limits when x approaching 2, negative 1 over x minus 1. By substituting the value 2 minus 1, we will have 1. Finally, f prime 2 will be equals to negative 1.
Okay, so sekarang kita tengok semula ya. Sebenarnya apa yang anda perlu buat adalah ikut formula yang diberi. Okay, so sekarang kita minat tentang 2. That's why kita punya A adalah 2. Kemudian kalau you tengok sini, dia tulis function fx. So bermakna dia kita pun ikutlah function fx. Nampak? Function fx. Minus fa di sini. Maksudnya di sini kita nak minta f2, iaitu nilai y ketika x sama dengan 2. So, kalau kita ganti, kita dapatlah 1. Okay, kita dapat 1. So, substitute. Kemudian, you perlu buatlah mathematical algebra kan. Buat, okay, sehingga you nampaklah situasi dia. So, apa maksud ini ya? Apa maksud ini? Iaitu gradient. Faham tak? Gradient. Pada ketika x sama dengan 2, gradient di kawasan itu adalah apa? Inilah jawapan dia, negative 1. So, inilah ya salah satu cara kita buat atau kita guna derivative. Okay, formula untuk derivative of a function.
Another example, find the f prime x if the function fx is equals to square root of x minus 2. So, given the formula, f prime a is equals to limits when x approaching a for the function fx minus f a over x minus a. So, let's begin. F prime 3 is equals to limits when x approaching 3 for the function square root of x minus 2 minus f a. So in here the a is 3. So if I substitute 3 minus 2, we will have square root of 1. And the square root of 1 will be equals to 1. So we will have minus 1 over s minus 3. So by substituting the value 3 minus 2, we will have 1. And we will obtain 0 for the numerator. And same goes to the denominator. So in here we call it indeterminate form. So for this case,
okay, so sekali lagi perkara ni berlaku IDF. Okay, ini kosong-kosong kosong-kosong ada 3 strategi. So ingat semula. So kalau saya nampak sini ada square root, maksudnya multiply by the conjugate itu penting lah.
there are several strategies that can be used to solve this kind of situation. Number 1, multiply by the conjugate. Number 2, factorize the situation. So in this case, the method we are going to use will be multiply by the conjugate. So f prime 3 equals to limits when x approaching 3, square root of x minus 2 minus 1 over x minus 3. The conjugate will be square root of x minus 2 plus 1 over square root of x minus 2 plus 1. Next, we are going to expand the situation and only expand the numerator. So f prime 3 equals to limits when x approaching 3. If we expand, we will have x minus 2 plus square root of x minus 2 followed by negative x minus 2 minus 1 over x minus 3 bracket square root of x minus 2 plus 1. So simplify the situation. We will have 0 for this part and then negative 3. So finally, f prime 3 equals to limits when x approaching 3, x minus 3 over x minus 3 bracket square root of x minus 2 plus 1. If we simplify the situation, f prime 3 equals to limit when x approaching 3, 1 over square root of x minus 2 plus 1.
So ingat semula ya. So bila kita deal dengan limits, kalau masih ingatlah ya, ingat ya, expand only one part. So untuk bahagian ni, bahagian bawah kita copy, yang atas tu kita expand. So ingat, berhati-hati. So seterusnya,
So if we substitute the value 3, we will have 1 plus 1. So finally, f prime 3 will be equals to 1 over 2.
so contoh ini lebih kurang sama macam tadi, cuma situasi yang diberi berbeza. So sekarang kita akan masuk ke example yang seterusnya. So untuk example ini anda perlu beri perhatian lah ya, sebab ini tentang soalan differentiable. Okay, buat remark, jot down, ini penting.
Example, given the function fx, we have a piecewise function. Find the value of f prime 1. So before we start the discussion, here we have a formula. F prime a is equals to limits when x approaching a for the function fx minus fa over x minus a. Next, we are going to illustrate the situation or the function in the form of number line. So for the first function, x is less than or equals to 1, meaning that for the left hand side, so the function would be 2x minus 1. The next one will be x greater than 1, so the function will be x squared on the right. So now let's begin the discussion. Find the value of f prime 1. So limits when x approaching 1 for the left. So the function of fx would be 2x minus 1 minus f1. So in this part, we are going to apply the function 2x minus 1, because if the value is 1, then the function would be the left-hand side. So 2 multiplied with 1, we have 2 minus 1. So meaning that our answer will be minus 1 over x minus 1. So if we simplify the situation, limit when x approaching 1 from the left, we have 2x minus 2 over x minus 1. Next, I'm going to factorize the situation where we will have 2 bracket x minus 1 over x minus 1. Finally, limits when x approaching 1 from the left, the value will be 2. So the answer will be approaching 2 when x approaching 1 from the left. Next, we
So untuk keadaan ini, nampak tak? Kita ada piecewise function. So kalau ada piecewise function, kita mesti kena ikut situasi yang diberi. Okay, so sekarang kita fokus kepada 1 from the left. So sekarang kita kena pergi 1 from the right. Dan kita tengok limit exist or not. Kalau limit exist, maksudnya situasi ini differentiable.
are going to begin the discussion from the right. So limits when x approaching 1 from the right. For the function fx would be x squared. For the f1, it will be equals to 1. So the value will be minus 1 over x minus 1. Next, if we substitute the value, we will obtain 0 over 0, which is indeterminate form. So in this part, I'm going to factorize the situation, and we will have limits when x approaching 1 from the right, x minus 1, x plus 1 over x minus 1. So after we simplify the situation, we will have limit when x approaching 1 from the right, x plus 1. And we will have approaching value 2. Since the limit when x approaching 1 from the left for the function fx minus 1 over x minus 1 is equals to limits when x approaching 1 from the right for the function fx minus 1 over x minus 1. So limit for the left and limit for the right is the same, which is equals to 2. So meaning that fx is differentiable at x equals to 1. Or we can say f prime 1 is equals to 2.
So sekarang kita dah ada beberapa contoh ya tentang yang pertama first principle. Tadi rujuk formula lah ya. So tadi punya formula adalah h over h. So sini pun h approaching 0. Formula kedua adalah derivative of a function at a point. So inilah formula dia untuk situasi yang kedua. So dalam bahagian pertama ini, iaitu 9.1 ini, iaitu kita bincang tentang first derivative, di mana ada dua formula. Satu adalah over h, satu lagi adalah over x minus a. So selesai bahagian pertama. So bahagian kedua, kita akan masuk ke rules of differentiation. So sekarang kita berada pada bahagian yang kedua, okay, iaitu rules of differentiation. So secara keseluruhan, anda nampaknya kita ada 9 kotak, maksudnya kita ada 9 situasi yang diberi. So mari kita mula.
In this video, I'm going to discuss the rules of differentiation. So kindly refers to this page, and we have several types of differentiation. So the first one is fx equals to k, where the k is a constant. If we differentiate the f, we will have f prime x is equals to 0, because every time when we differentiate constant, we will have 0. Or you can write it as dy dx equals to 0, or you can write it as y prime equals to 0. Second, we are going to focus fx is equals to k, where k is a constant, multiply with x to the power of n, where n is also a constant. So for this situation, f prime x will be equals to, kindly focus on the x. So we will have n multiplied with x, n minus 1 bracket. So finally, the f prime x will be equals to kn multiplied with x to the power of n minus 1. The third one would be fx is equals to 1 over square root of x. So before we start differentiate the situation, kindly modify the situation, and we will have x to the power of negative 1 over 2. If we differentiate, we will have f prime x equals to negative 1 over 2, x to the power of negative 1 over 2 minus 1. F prime x will be equals to negative 1 over 2, x to the power of negative 3 over 2. Rewrite the situation, and we will have negative 1 over 2 square root of x to the power of 3.
So sekarang kita dah bincang ya, dua. Sebenarnya ada dua sahaja. Okay, number one is a constant. Okay, number one is a constant. Number two, we have a function k, okay, for the polynomial x to the power of n. So 2 dengan 3 ni sebenarnya sama. Okay, 2 dengan 3 ni sama. So sekarang kita akan bergerak ke product rule, quotient rule and chain rule.
Situation number 4, we have a product rule. The formula for the product rule will be dy dx, where we will have v multiplied with du dx plus u dv dx. In other types of situation, we will have dy dx is equals to v multiplied with u prime plus u multiplied with v prime. Number 5, we have quotient rule. So quotient rule, we will have dy dx equals to v u prime minus u v prime over v squared. Next, we will have number 6, which is a chain rule. dy dx is equals to dy du multiply with du dx.
So, berkenaan dengan product rule, chain rule, quotient rule kan? Saya mula dengan V dulu. Okay, saya mula dengan V dulu. Sebab product rule dengan quotient rule, dia punya numerator tu sama. Okay, dia punya numerator tu sama susunan dia. Beza dia adalah product rule dia tambah, quotient rule dia minus. Itu adalah pendapat saya lah. So mungkin dalam SPM dia mula dengan U dulu kan? Betul? Sekarang saya minta ya modify sikit, iaitu kita mula dengan V dulu. So kalau you tengok dia hampir sama, cuma beza dia satu plus, satu minus. So chain rule ini pun sama, kita revise mula apa yang kita belajar semasa SPM. Seterusnya, benda yang mungkin baru kepada anda iaitu exponential function, kemudian kita ada ln, and then kita ada trigo. Okay? So ingat ya, ingat macam mana beza dia exponential function dengan polynomial, iaitu nombor 2 dengan nombor 7. Beza dia adalah kalau nombor 2 dia punya base adalah variable. Okay? Power dia adalah constant. Kalau untuk number 7, dia punya base adalah constant, and then dia punya power adalah variable. Beza dia. Okay? Kita tengok secara ringkas macam mana kita nak deal with 7, 8 and 9.
Number 7, we have differentiate exponent to x respect to x. So the step would be copy the situation, kindly focus on the power and differentiate it, and we will have 2. So rewrite the situation, differentiate e to the power of 2x respect to x, and we will have 2e to x. Next, number 8, we are going to differentiate ln x. If we differentiate ln x, we will have 1 over x. Then focus on the internal function and differentiate the x, and we will have 1. Rewrite the situation, d dx ln x, we will have 1 over x. In number 9, we are going to differentiate trigo. So we are going to further the discussion in the next session.
So kalau you tengok semula, saya ulang ya, number 7. Macam mana nak differentiate exponent? Exponent tu bagi saya adalah you salin semula. Okay, you salin semula. Kemudian you rujuk power dia, you differentiate. So you dapat 2. So itu adalah cara kita deal with exponential function. Salin semula, rujuk power, differentiate dia. Okay, nombor 8 kalau deal with exponent. Nombor 7 kita deal with exponent, nombor 8 kita deal with ln. Okay, kita hanya boleh differentiate ln. Kalau log base lain iaitu tak mampu, kita kena tukar guna properties atau law atau rules of log untuk tukar jadi ln sebelum kita bertindak. Yang pertama, mesti ln atau log base e kemudian kurungan ini. Okay, kalau jumpa ln dia adalah 1 over. Okay, kemudian rujuk internal function, differentiate dia. Ulang suara, ln adalah 1 over. Dalam ini kalau x plus 1, bawah ini pun x plus 1. Kemudian rujuk dalaman punya function, differentiate dia. So itu adalah cara untuk deal with ln. Seterusnya kita akan bincang trigo. Ada 6 jenis trigo asas yang kita boleh differentiate. So mari kita tengok contoh. So ini adalah asas kepada differentiation untuk trigo. Ada 6 asas.
So I'm going to discuss the differentiation. Here we are going to differentiate the situation for trigonometry. Number 1, differentiate sine x. And we will have cos x. Then, focus on the internal function where we have x. Do remember to differentiate the x and we will have 1. So at the end, differentiate the sine x with respect to x, we will have cos x. Next, second one, differentiate cos. Please take note, we have negative sine x. Again, focus the internal function, kindly differentiate the situation, and we will have 1. So, differentiate cos x respect to x, we will have negative sine x. The third situation, differentiate the tangent x with respect to x, and we will have second square x. Do remember, differentiate the internal function where we have 1. So, differentiate tangent x with respect to x, we will have second square x. Number 4, differentiate cotangent x, and we will have negative cosecant square x. Do remember, differentiate in the internal x, and we will have 1. So finally, differentiate cotangent x respect to x, we will have negative cosecant square x. Next, number 5, differentiate second x respect to x. So we will have second x tangent x. Then, differentiate the internal x, and we will obtain 1. So, differentiate second x respect to x, we will obtain second x tangent x. Finally, differentiate cosecant x, and we will have negative cosecant x cotangent x. Do remember to differentiate the x, and we will obtain 1. So finally, differentiate cosecant x respect to x, we will have negative cosecant x cotangent x. So here are the basics for differentiation for the trigonometric function.
So kalau kita rujuk ada 6, boleh? So basic dia, okay, itu adalah asasnya. So ingat mesti sentiasa rujuk luar dulu, kemudian baru dalam. So itu adalah situasi untuk trigo. So kalau you nampak ada special sikit kita ada differentiate dan kita dapat positif, ada yang kita dapat negatif kan. Saya bagi you hints. Differentiate sesuatu benda yang mula dengan C. Cos, cotangent, cosecant. You perasan tak? Semua depan dia ada negatif. Okay? So itu adalah hints dia lah. So ini adalah rules of differentiation. Okay? Kita ada berapa? So number 1 adalah constant. Number 2 adalah polynomial. Okay? So number 3 dengan number 2 sama. Number 4 adalah product. Then quotient, number 5, and then number 6, chain rule. Number 7 adalah exponent. Number 8 adalah ln. Number 9 adalah trigo. So beri perhatian 7 dengan 8 jangan keliru. Okay, jangan keliru. Number 8 hanya boleh differentiate untuk ln saja. Kalau perkara itu bukan log base E, mohon tukar guna properties atau rules atau law of log untuk tukar jadi ln dan baru differentiate. Okay, so seterusnya kita akan bincang okay, tentang example. Makna dia 9 kotak tadi kita akan campur dan kita differentiate satu persatu. Sebagai ulang kaji lah. So yang pertama you boleh tengok you kena check dalam 9 tu yang tadi punya rules kan. Ini adalah apa? Okay. So saya boleh bagi tahu untuk 1, 2, 3, 4 semua adalah constant. So, jangan terperangkap. Ini bukan nombor 7, bukan eksponen. Ini bukan nombor 8, bukan keluarga log. Ini bukan keluarga exponential. 1, 2, 3, 4 ini semua adalah constant. So kalau constant macam mana? Kita akan dapat apa? So kalau you nampak semua adalah constant. Boleh? Sebab 1 until 4 ni semua adalah keluarga constant. So you akan dapat semua zero. So itu adalah situasi yang pertama. So seterusnya kita akan bergerak ke mana pula? Kita akan bergerak ke example yang kedua dalam rules of differentiation, iaitu dalam keluarga polinomial.
So number 5, here we are going to differentiate y equals to 6x plus 5x squared. Kindly refers to the rules of differentiation. So dy dx will be equals to 6 plus 5 multiplied with 2, where we have the 2 as a power, then x to the power of 2 minus 1. Rewrite. So dy dx is equals to 6 plus 10x. Here we have number 5.
Okay, so itu adalah revision saja bagaimana untuk differentiate. So ingat apa-apa pun anda perlu modify sehingga situasi macam nombor 2 tadi. Rules of differentiation nombor 2 iaitu k x to the power of n. Okay, so sama juga nombor 6 dengan nombor 7. So sila tengok nombor 6. So nombor 6 ni kita dapat 2x squared, tiada masalah. Tetapi untuk 1 over x ini kita perlu buat sedikit modification. Boleh? Kita perlu buat modification, iaitu kita kena bring up then ingat rules of indices. Modify dia. Kemudian kita differentiate dia macam biasa, akhirnya kita dapatlah jawapan kita. Kemudian nombor 7, you tengok kita ada banyak layer. Okay, iaitu 2. Yang pertama, anggap benda ini satu elemen, okay, satu elemen di luar the square. Macam mana you differentiate 5x square? Betul? You 2 bawa ke depan jadi 10 kan? Sama juga di sini. 2 bawa ke depan, settle luar, masuk pula dalam. Differentiate dalaman. So yang ini kita panggil internal function. So untuk situasi ini sebenarnya kita boleh guna chain rule. Okay, kita guna chain rule. So kalau you nampak lah. Kalau tidak pun tak mengapa. So boleh tak kita buat expansion dan baru differentiate? Pun boleh. Ada macam-macam strategi you boleh guna. So harap anda revise semula lah. Iaitu situasi rules of differentiation number 2 and number 3. Okay, kita teruskan lagi.
Now we have number 8. So dealing with this kind of question, we can expand the situation.
So bila selesai soalan macam ni, kita kena tengok. Okay, kita berada di rules yang kedua ke? Rules yang ketiga ke? Ke kita nak guna product rule? Atau quotient rule? Atau chain rule? Okay, ini soalan nak menguji kita punya kemahiran untuk membuat keputusan, memilih. Okay, rules dah sepatutnya ketika menjawab soalan differentiation ini.
Y will be equals to 2x multiply with square root of x plus square root of x. So y will be equals to 2x multiply with x to the power of 1 over 2 plus x power of 1 over 2. So by using the properties of log and the indices, so we can simplify it as y is equals to 2x 1 plus 1 over 2 plus x 1 over 2. So finally, y will be equals to 2x power of 3 over 2 plus x to the power of 1 over 2. After we simplify the situation, then only we begin our differentiation. So
kalau untuk soalan ni, apa yang telah berlaku? Kita tak guna produk, kita buat expansion. Okay, kita buat expansion, kemudian baru kita differentiate. Kita tengok pula soalan nombor 9. Kita nak guna quotient rule ke, product rule ke? Kita tengok keadaan seterusnya.
We will have dy dx equals to 2 bracket multiply with the power where we have 3 over 2 and then x to the power of 3 over 2 minus 1 plus Again, multiply with the power 1 over 2, x to the power 1 over 2 minus 1. Finally, dy dx is equals to 3x to the power of 1 over 2. Plus, we have 1 over 2 multiplied with x to the power of negative 1 over 2. Rewrite the situation. So y is equals to 3 square root of x plus 1 over 2 square root of x. Let's proceed with number 9. So before we begin the differentiation, kindly simplify the situation. So now we have y is equals to x to the power of 3 over x plus 4 over x. So y will be equals to x squared plus 4x power negative 1. Kindly modify the situation and get ready with the process of differentiation. So we will have y prime is equals to 2x, where we have 2 minus 1, plus 4 multiplied with the power negative 1. Then we have x to the power negative 1 minus 1. So y prime will be equals to 2x minus 4x to the power negative 2. dy dx will be equals to 2x minus 4 over x square.
Ulang kaji sahaja. Okay, untuk differentiation. So sekarang kalau you tengok kita dah selesai lah rules of differentiation, iaitu part number 2. Okay, part number 1 adalah first principle dengan derivative at a point x equals to a. Kemudian bahagian kedua adalah rules of differentiation. Betul? Kemudian dalam rules of differentiation kita ada 1, 2, 3. Okay, so sekarang kita akan masuk ke product rule, quotient rule dengan chain rule.
We have the example for the product rule and the quotient rule. Kindly refers to number 10, where we have x cubed multiplied with x minus 3 power 5. It is very difficult for us to expand x minus 3 to the power 5. So this is the place where the product rule comes in. So before we begin, kindly name it as u for x cubed and v for x minus 3 to the power 5. So here we have the formula for the product rule, where we will have dy dx is equals to v u prime plus u v prime. So in here, u will be x to the power of 3, and we have v is equals to x minus 3 to the power of 5. Kindly differentiate the u respect to x, and we will have 3x squared. As for the v, dv dx will be equals to 5 bracket x minus 3 to the power of 4. Do remember to differentiate the external function, which is x minus 3, and we will have 1. So we denoted it as u prime for 3x squared, and then we have v prime, which is equals to 5 bracket x minus 3 to the power of 4. Kindly substitute to the formula, and we will have dy dx, where we have v x minus 3 to the power of 5, and we have u prime 3x squared plus, where we will have u, which is x cubed, and then followed by v prime 5 bracket x minus 3 bracket power 4. So simplify the situation.
Okay, so saya haraplah you boleh ingat semula bila saya dah buat revision ini. Okay, so ketika SPM anda telah belajar iaitu u, iaitu v, then du dx, dv dx, and then substitute. Betul? Kemudian setelah you dah siap, okay, you dah siap, you akan expand. So kalau boleh nampak common factor, kita factor out, dan kita menulis dengan cara yang sepatutnya, iaitu the simplest form. Okay, the simplest form.
Y prime equals to x squared bracket x minus 3 power 4 bracket 5 plus with the 3 we'll have 8x minus 9.
Okay, so kita ada dua kaedah atau cara untuk menjawablah. So ini adalah yang pertama. Faham tak? Yang pertama iaitu masa you buat ketika SPM. Okay, so dy dx sebenarnya sama dengan y prime, sama juga dengan f prime x. Sama saja. Okay, so untuk example ini, buat sementara waktu saya masih fokus dekat product rule. Cuma beza dia dengan yang tadi. Yang tadi saya nyatakan satu persatu kan. Yang ini saya buat shortcut. Okay, saya buat shortcut. Maksudnya saya hanya ingat formula sahaja untuk product rule. Kemudian saya straightforward jawab soalan tersebut.
So here I'm going to show how to use the product rule to solve this kind of situation. So now let the u become x minus 4 and v as square root of x plus 2. So the formula for product rule will be y prime equals to v u prime plus u v prime. So bear in mind where we have u is equals to x minus 4 and v, we need to do some modification where we have x plus 2 to the power of 1 over 2. So now let's begin. Y prime equals to v. So meaning that we have square root of x plus 2. Then followed by u prime. Refers to the situation, if we differentiate the u with respect to x, we will obtain 1. Plus, followed by u. So in here, u will be x minus 4. Next, focus on v. Differentiate the v with respect to x and we will have 1 over 2 bracket x plus 2 to the power of negative 1 over 2, because 1 over 2 minus 1 we will obtain negative 1 over 2. Do remember, focus internal function and we differentiate, so we will have 1. Kindly simplify the situation.
Okay, so haraplah ya anda nampak beza. Okay, example tadi dengan example ini. So yang ini saya fokus apa? Saya fokus kepada formula. So kalau you nampak, saya anggap ni u, ini v. Okay, v saya salin. U saya differentiate straightforward. Faham tak? Saya differentiate straightforward. Saya differentiate dalam sini, then menulis. Jangan risau, boleh punya berlatih. Okay, kemudian u saya copy, kemudian saya differentiate yang belakang ni. So saya dapatlah jawapan ini. Okay, jangan lupa differentiate dalam ni dapat 1, tulis di belakang ini. So saya biasalah, saya kata apa? Salin belakang, differentiate depan. Tambah salin depan, differentiate belakang. Macam itulah kaedah saya. That's why saya kata tricks and tips. Okay, so dalam exam nanti pun sama, buat assignment ke apa ke pun sama, iaitu buat dengan cara yang pantas, straightforward. Tak perlu lagi buat macam kaedah lama, UV kena nyatakan satu persatu. Kita boleh straightforward saja. So apa yang you perlu buat adalah biasakan diri, kemudian berlatih. Okay, berlatih.
So y prime equals to square root of x plus 2. Plus, we have x minus 4 over 2. So in this part, we have negative 1 over 2, meaning that square root of x plus 2. Next, simplify the situation. Meaning that we have to equate the denominator. So y prime equals to square root of x plus 2. Multiply with a 2 over 2 square root of x plus 2. Plus x minus 4 over 2 square root x plus 2. So y prime will be equals to 2 bracket x plus 2 plus x minus 4 over 2 square root of x plus 2. Y prime will be equals to, we have 2x plus 4 plus with x minus 4 over 2 square root of x plus 2. Finally, y prime will be equals to 3x over 2 multiply with square root of x plus 2.
Okay, so kalau you nampak lah ya, itulah cara dia. Okay, ketika deal with product rule. So seterusnya saya akan bergerak ke quotient rule pula.
We are going to apply the quotient rule. Why we're using quotient rule? Because of the situation, which is a rational situation. So kindly name it as u, and we have v. So before we start, we have the formula for the quotient rule, which is dy dx is equals to v u prime minus u v prime over v squared. So now we name u as a x cubed, followed by v, where we have x minus 3 to the power of 5. Differentiate the u, you have du dx, which is 3x squared. Focus on v, where we have dv dx equals to 5 bracket x minus 3 to the power of 4, multiply the internal function, and we will have 1. So we denoted the du dx as u prime. And for the dv dx, v prime. So now, kindly substitute the situation into the formula. So dy dx is equals to v, where we will have x minus 3 to the power of 5, multiple with the u prime, 3x squared. Next, minus, we have u, where the u will be the x cubed, multiply with 5 bracket x minus 3 to the power of 4 over v squared. So x minus 3 to the power of 5, here we still have square. So simplify the situation, y prime will be equals to x minus 3 power 5 bracket 3x squared minus 5 x cubed bracket x minus 3 to the power of 4 over x minus 3 to the power of 10. Focus on the numerator and then begins to expand and also factorize and then simplify. So in this part, my strategy will be factor the situation where we have a common term, which is x minus 3 to the power 4 and also the x squared. So we will have x minus 3 multiplied with 3 because we already factored out x minus 3 power 4 and also the x squared. So left behind x minus 3 and then 3. Next, minus with, we have factor the situation x minus 3 power 4 and also the x squared. So we will have negative 5x over x minus 3 to the power of 10. Next, we can y prime equals to x minus 3 to the power 4 x squared bracket 3x minus with negative 5x, and we will have negative 2x, then negative 9 over x minus 3 power of 10. Notice that we have a common terms and we can simplify the situation. So now y prime will be equals to, simplify, then we will have x squared bracket negative 2x negative 9 over x minus 3 to the power of 6.
Okay, so itu adalah cara lah untuk saya guna quotient rule. So ini adalah revision sahaja. Boleh? Revision sahaja. Untuk you punya SPM, you akan buat UV satu persatu kan, then you substitute dalam formula kan, betul? So itulah cara dia untuk menjawab soalan quotient. So setakat revision saja. Okay? Dalam metrik ini, so kalau untuk quotient rule, saya akan buat kaedah macam ni. Sekali lagi, tricks and tips. Okay? So saya tak nyatakan semua, saya just ingat formula dia, then straightforward saya dapatkan jawapannya.
Here we have the example for applying the quotient rule. So let's let x minus 4 as u and square root of x plus 2 as a v. So the formula for quotient rule will be dy dx is equals to v u prime minus u v prime over v squared. So bear in mind, we have u is equals to x minus 4 and v we have x plus 2 to the power of 1 over 2. Let's begin. We have y prime is equals to v, where we have x plus 2 to the power of 1 over 2. Multiply with u prime. Kindly focus on u. Differentiate with respect to x. So we will obtain 1. Minus, we have u. So in here u will be x minus 4. v prime. Kindly focus on v. Differentiate the situation. 1 over 2. Bracket x plus 2 to the power of 1 over 2 minus 1, and we will obtain negative 1 over 2. Do remember, differentiate the internal function and we will have 1. So finally, v squared. So square root of x plus 2 power 2. Simplify the situation. Y prime will be equals to square root of x plus 2 minus, we have bracket x minus 4 divided by 2. Focus on this part and we will have square root of x plus 2 as the denominator over x plus 2 after we simplify the situation. So first, focus on the numerator part, equate the denominator. So meaning that y prime will be equals to square root of x plus 2 multiply with 2 square root of x plus 2 over 2 square root of x plus 2 minus bracket x minus 4 over 2 square root of x plus 2 over x plus 2. Simplify the situation. So we will have y prime equals to 2 bracket x plus 2, because after we multiply with the element square root x plus 2 square root x plus 2, and we will have x plus 2 minus x plus 4 over 2 square root of x plus 2 divided by x plus 2.
Okay, so untuk example ini mungkin dia rumit sikit lah. Masih sama, kena berlatih. Okay, kena berlatih. So konsep dia lebih kurang sama, cuma saya tak nyatakan UV saja. Saya buat straightforward. Maksudnya, saya salin yang bawah, okay? Kemudian saya differentiate yang atas. So saya dapat ini. Minus, saya salin yang atas, saya differentiate yang bawah. Okay? Kemudian V squared. Teruskan, saya ringkaskan dia. So berhati-hati, bila kita ada situasi ini, harap you ingatlah macam mana nak flip. Okay, macam mana nak flip. So, ini adalah contohnya lah macam mana saya buat quotient rule. So, ingat kena berlatih.
We will obtain y prime will be equals to 2x plus 4 minus x plus 4 over x plus 2 square root multiply with 2 in here. Divide, we need to convert to multiply, so we have to flip the situation. So in here we will have x plus 2. So y prime will be equals to x plus 8 over 2 bracket x plus 2 power of 1 over 2 multiply with x plus 2 power of 1. By using the properties of log indices, we can combine the situation, and finally y prime will be equals to x plus 8 over 2 bracket x plus 2 to the power of 3 over 2. So here we are, and thanks for watching.
So saya haraplah you nampak ya macam mana saya buat product rule, macam mana saya buat quotient rule. Okay, iaitu tips. Okay, tips dia macam mana nak buat dengan laju. So harap anda belajar kemudian berlatih. So satu lagi contoh untuk produk quotient dengan kita ada chain rule. Okay, untuk bahagian nombor 3 ini.
The example of the differentiation. Y is equals to x plus 2 over x plus 3. So before we begin,
so ingat jangan nampak macam ni. Okay, straightforward quotient rule, straightforward product rule, tak perlu. Ingat pilihan rules of differentiation sangat penting. So kita dah buat nombor 1 constant, nombor 2 adalah polynomial, nombor 3 pun polynomial, nombor 4 tu product, nombor 5 tu quotient, nombor 6 tu chain rule. So kita ada 6 sahaja yang kita tengah main. Okay, so bahagian pertama ingat first principle derivative of a function at the point A, itu bahagian pertama. Bahagian kedua adalah rules of differentiation. Bahagian ketiga adalah perbincangan, iaitu nombor 1, 2, 3, 4, 5, 6 untuk rules of differentiation.
against the differentiation, so kindly modify the situation. So in here, my suggestion would be, by using the long division, propel the situation. So here we have x plus 2 as a polynomial, x plus 3 as a divisor. So 1, we will have x plus 3. And finally, we have negative 1. Rewrite the situation, y will be equals to 1 minus 1 over x plus 3. Again, modify the situation. So y will be equals to 1 minus bracket x plus 3 to the power of negative 1. Next, differentiate the situation with respect to x. So dy dx will be equals to, differentiate 1, we will have 0. Negative, multiply with the power where we have negative 1, bracket x plus 3 to the power of negative 2. Kindly differentiate the internal function x plus 3 and we will have 1. Rewrite the situation, dy dx is equals to 1 over x plus 3 to the power of 2.
Okay, so kita dapatlah contoh macam ni. So tak semestinya kena guna product rule, quotient rule. Mungkin kita boleh guna knowledge yang kita ada dalam polinomial untuk menjawab soalan ni pun boleh. Okay, so itu just nak bagi anda pengalaman. Seterusnya,
first, modify the situation where we have y is equals to x squared plus 1 to the power of negative 4. Next, differentiate the situation, dy dx equals to negative 4 bracket x squared plus 1 to the power of negative 5. Do remember to differentiate the internal function and we will have 2x. Y prime will be equals to negative 8x over x squared plus 1 to the power of 5.
So berkenaan dengan contoh ini pun sama. Kita nampak ya, kita boleh modify situasi dia, okay? Iaitu rules of indices. Kemudian sebenarnya soalan ni adalah chain rule. Nampak? Kita fokus yang luar dulu, kemudian baru masuk dalam. Okay? One by one, layer by layer. So haraplah anda boleh nampaklah ya, rules of differentiation yang saya bincang nombor 1, 2, 3, 4, 5 dan 6. So ini adalah situasi untuk differentiation. Thank you.